Welcome in this session. In this session, we understand what is graph traversal and implement graph traversal algorithms in Python. First of all, we take an overview. What do you mean by graph? A graph is a non-linear data structure which is represented by vertex, that is also called nodes and edges. Every pair of vertices is connected with one edge between them. Graph has many real life applications which we can see in our day-to-day life. For example, graphs are used widely in networking area like social media network, telephone network, etc., where a single user can be represented as a node and the relationship between the users can be represented as edge. You see the graph in our screen. There are also type of graph, directed graph or undirected graph. In directed graph, we give the direction that is so in our graph, 0 have direction to 1 and 0 is connected to 2. 1 is connected to 2 on and 4. Vertex number 2 is connected to 3 and vertex number 3 is connected to vertex number 4 and 4 have no connected or indirection vertex. So a graph is mainly implemented in two following ways, or that is called graph representation. First one is the adjacency matrix and another one is the adjacency list. In the adjacency matrix, we take or create a two-dimensional array and each cell 1 comma j, that is one is a node and j is another node, represent if there is an edge that exists between node I and j, then we take the cell value 1, otherwise the cell value is 0. So in the given example, we clearly see that 0 is connected to 1 and 0 is connected to 2. So 0 is connected in 1, we take value 1 in 0 to 1 and we take value 1 in 0 to 2. Remaining all are zeros for the node number 0 and so on. Now, adjacency list. In this example, we consider a undirected graph. It is just like a linked list. 10 is connected to 20 and 20 is connected to 40. 20 is also connected. So this is an undirected graph. So 10 is connected to 20 and 20 is also connected to 10. 20 is connected to 10, 10 to 30 or 30 to 40. This is called adjacency list. Now, graph traversal. There are two types of traversal algorithm given. First one is the BFS, breadth first search, and another one is the DFS, depth first search. In our BFS is a graph traversal algorithm where we start from a selected source node and traverse the graph label by label by exploring the neighbor node at each level. So we can say that the node exists at the same level or traverse first, then move to the another level. But in DFS, where we start from a selected source node and go into the depth of this node by recursively calling the DFX function until no children are encountered. When the dead end or the leaf node of a particular way is reached, this algorithm backtrack and start visiting the other children of the current node. For implementation purpose, we choose programming language that is Python. Here you see the algorithm that is work or that is implemented in Python. We consider the following graph for traversal purpose. Let's move on our programming. The given graph or given algorithm implemented in Python, here to create the adjacency list, we consider given data structure in Python that is called dictionary. Dictionary have the concept of key and values where 0, in the previous example you clearly see, where 0 is connected to 1 and 2. So 0 have two values, 0 is 1 and 0 is 2. 1 is connected to 2 and 4, 2 is connected to 3, 3 is connected to 4, and 4 have no index and age, so 4 have no value. Now we consider two queues, that is visited and queue. They are the two empty lists that are used in our example. So we create a function that is called BFS. Pass the argument. What arguments are passed? There are three arguments passed or three parameter passed. One is the visited, graph, and node. Graph, that means pass the adjacency list. Visited means pass the visited queue, and node means where is your or what is your starting node. You tell the function what is your starting node from where you start your traversal. Now in the next line, visited dot append. So let's see our driver code. In our driver code, you clearly see BFS pass three arguments and we start our traversal from the node number 0. Node number 0, graph. Graph means adjacency list that is created is passed, and visited, that is empty list, is also passed. Now append. Append means add the or enqueue the first node, that is the starting node in our visited list. Queue dot append. Also queue is also enqueue with the starting node. While queue, that means while queue means until the queue have value, then loops are continue executed. This print the adjacency node. This is for visualization. And m equal to q dot pop 0. B dequeue the element from the our queue. For neighbor in graph M, if there is adjacent nodes in graph or nodes is not visited, if neighbor not in visited, then append visited dot append dot neighbor queue dot append neighbor. Return the visited queue. Let's run this code on our integrated development environment that is called IDLE. This is the implementation, and we run this. So in this example, you clearly see that in the given example, you clearly see that this is the adjacency list that is passed as an argument. 0 is connected to 1 and 2, and 1 is connected to, and so on other end, and adjacent node. First one 0, visited queue also have 0. Adjacent node for 0 is 1 and 2, visited queue 0, 1, 2. Adjacent node for 1 is 2 and 4. So visited queue have 0, 1, 2, 4, and so on. 2 is 2 is connected with 3, and 3 is connected with 4, and 4 have no. So this is the visited order, that is 0, 1, 2, 4, and 3. This is the visited order for the given graph. Now let's move on our next topic, that is DFS. For the DFS, that is also, we also consider the same graph for the DFS depth first search. This is the given algorithm that is implemented in Python to create adjacency list. We again consider dictionary. We take a visited set. Set is so to remove the duplicacy. We consider set. This is the function where three arguments pass: visited, graph, and node. If node not in visited, then add into the visited set or queue. For neighbor, that is adjacent in graph, then again call or recursively call the DFS again and again until we reach the end of each successfully. End of each is written digital. So come to the implementation, or ideally is the code, and we run this code. Following code is running successfully. This is the graph or adjacency list, and this is the budgeted order for the DFS. So we successfully implement the DFS in Python and BFS in Python. These are the references.